You are a fresher, budding developer, or an experienced programmer, whatever you be. When you work with Java programs, you deal with constructors. They are the basics of the object-oriented programming, and it becomes essential for you to know everything about it. This video gives you an insight into what a constructor does, overloaded constructors, different types of constructors, and a lot more. To simply put, constructor is a mechanism that helps you to create an instance of the class. It helps you to create objects. You can initialize the values of the instance variable associated with the class while creating the object of that class using the constructor. Constructor declaration looks like a method declaration, except that they use the name of the class and have no return type. Every class declaration comes up with a default constructor. Java knows if you want to use this class, you need an object, and to create this object, you need to use a constructor. So Java provides a default constructor implicitly for every class you create. We will see in a while how we can define our own constructors, but when we don't define a constructor explicitly, Java uses this default constructor to instantiate the object. This will internally call the super method to get the object created. Here we have the person class with 3 instance variables, the first name, last name, and the age. I will override the toString method for this class. This will help us in printing the object contents later. To create an object of this class, we say person1 equals new person. This is the default constructor. The new keyword here does a whole lot of things. When the new keyword is encountered, JVM calculates the memory required and allocates it for the object to be created in the heap where the object contents will be stored. The JVM looks into the class, checks for the instance variable types. In our case, we have 2 strings and 1 integer type, and thus allocates enough memory space for them. Then the JVM will assign the default values to the instance variables. Next, it invokes the constructor which instantiates the person object, and finally initializes the object with the instance variables. And this is what happens behind the scene when you create an object. There are many theories that says the constructor initializes the instance variables with the default values, but the Java documentation says otherwise. The instance variables are initialized first and then the objects are created, and these variables are contained within the object. Here we create the object using the default constructor. Let me print the values of the instance variables. As you see here, we get the default values for them. The first name and last name are null and the age is 0. We can initialize these variables with our own values using the parameterized constructor as we create the object. I'll define a constructor like this. This constructor has 3 parameters, the first name, last name, and the age. This is the non-default constructor customized for our requirement. The constructor has an access modifier public and has the same name as that of the class. The access modifier can either be public or private only. Mostly it will be public, and there are occasions where we can have private constructors. I will talk about them later. We have 3 parameters here and they are assigned to the variables inside the constructor. A constructor with all the instance variables as parameters is called as the canonical constructor. Here we have the this keyword. I will remove it for a while. We have the first name equals first name. There is a confusion here now. These both are legal variables. One is the instance variable, the other one is the parameter we passed. You don't know which one is which, what you are assigning to what. Java is also confused like you. See the warning, it says the assignment to the variable has no effect. Inside any method, Java takes the scope of the variable defined within that method. Here, the first name and this first name both refer to the same local variable, that is the parameter we pass. That's why we get this warning. To differentiate, we need to tell the compiler that one of the variable is the instance variable. We use the keyword this to tell the compiler that this is the instance variable. This refers to the current instance in this case. It is clear now. The instance variable on the left hand side is assigned with the value from the parameter on the right hand side. If we use different names here for the parameters, then no need for this keyword, as we won't have any confusion. Let's create an object of this constructor. In the main method, I will say person2 equals new person of John, Smith, 30. We pass the first name, last name, and the age. Person2 object will be created with these values. But wait, we have an error here. It says the constructor is undefined. This is the default constructor we used a while ago to create person1. But it is not available now. What has happened? When we declare a constructor on our own, Java expects us to use that constructor to create objects and does not provide the default constructor. This is the reason for that error. But if you want to create an object without passing any parameter, like we have done here, then we need to explicitly declare a constructor without any parameters. So I will declare a constructor like this. This constructor has no parameters and is also called as the no argument constructor. The error is gone. This time, Java uses the no argument constructor to create the person1 object and not the default one. And remember, what we have created is again a custom constructor and not the default one. We will run the program now. We got two objects created, person1 with the default values and person2 with the arguments we passed. The custom constructor gives us some benefits. It is not just initializing the values, but we can do validation within these constructors. We can check for null values for the names and validate the age to be greater than 0. We can have more constructors with different parameters. We have a constructor here with two parameters, the first name and the last name. The first and last names are initialized with the values we pass, and the age will be set to the default value, that is 0. Also, we can have the same validation here. If you look at the code once again, we are repeating the whole stuff here. Your testing team will come up and say there is a code smell. They won't accept duplication like this. So we can rewrite this by using the other constructor. I will say this of first name, second name, 0. The keyword this here refers to the constructor. And as you see, we pass 3 arguments here, and this is nothing but the canonical constructor. When we use this constructor to create an object, it in turn will call the canonical constructor. So I will say person3 equals new person of Alex, Hales. The constructor internally will call the canonical constructor, which will do the validation, and if it finds the validation to be fine, creates the object. We also can have what is called as a copy constructor. It creates an object using another object of the same class. This is how we write a copy constructor. Here, as you see, the parameter is an object of the person class itself. And this constructor in turn calls the canonical constructor and passes the first name, last name, and age of the person object. I can say person4 equals new person of person3. This takes the first name, last name, and age of the passed-in object and creates a new object with the same values. Though person3 and person4 have the same values for their respective variables, they have different memory locations in the heap and different references. Copy constructor is used to create an exact copy of the object with the same values of an existing object. This is called a deep copy. Why do you need a constructor like this? When you have a complex object with many variables, it becomes easier to use a copy constructor. If you add a new instance variable to your class, you just have to change the copy constructor to take this new attribute into the account instead of changing every occurrence of the other constructors. The clonable interface gives the same effect as a copy constructor. That is, it creates a copy of the existing object. But copy constructor has more advantages than using the clonable interface. That discussion is beyond the scope of this video, and I am not going to discuss them here. So we have different constructors here. One is a no argument constructor, one has 2 parameters, another one has 3 parameters, and the other one has the class itself as the parameter. Each one has a different method signature, and this is what we call as the constructor overloading. For simple classes where default initializations are acceptable, there's no need to create an exhaustive set of overloaded constructors. However, as classes becomes more complicated and the initialization of instances becomes more nuanced, developers should provide customized set of parameter constructors to their users. As we have seen in the beginning, the constructor has the same name as the class. Anonymous classes don't have a name, and so we cannot have explicit custom constructors for anonymous classes. However, Java gives an implicit constructor for these type of classes. All the constructors we created so far had the access modifier public. This makes sense as we need to call the constructors wherever we need to create an object for the class. But can we have private constructors? This looks absurd, but we can have. Private constructors do not allow us to create objects. What? Then why we need them? But in real-time scenarios, there are several use cases where you have to prevent objects being created for a class. When you design a class using a singleton pattern, the builder pattern, or when you have delegating constructors, you prevent objects being created directly. In such cases, private constructors will be helpful. Here, I'll make this constructor private and modify the other constructors to use this private constructor to create the objects. The user may call any of the public constructors, but they all in turn will call the private constructor internally to create the object. This is what we call as the constructor delegation. There are times when you want to prevent anyone from creating an object of a class. If all the instance variables are static, then you can call them directly using the class name. No need to create an object for that. In that case, you don't need a constructor. But if you don't have any constructor, the user may call the default one and create the object. So declare only one private constructor for this class. Then the users cannot create an object. Java provides many internal classes like this. One classic example is the arrays class. So there you go. So we have seen the fundamentals of Java constructors in this video. We talked about the default constructor, the parameterized constructor, the canonical constructor, the copy constructor, and the private constructors, and also discussed how to use them and their advantages. I hope you have enjoyed this tutorial. Want to head over to Lenovate.academy? We have got a lot of great tutorials on Java and other topics. If you are interested, you can always follow me on my blog pages. I would love to hear from you, your thought on this tutorial. Please leave your comments at the bottom. If you are watching this on the YouTube, please subscribe to this channel and hit the bell icon. You will be notified whenever I post a new video here. Thank you for watching and see you again soon.